Right now, more than 5 million engines from 5 different automakers are under recall or federal investigation at once. GM, Toyota, Honda, Hyundai, and more. It is the largest multi-brand engine failure wave in modern history, with the damage already near $8 billion. This is not one bad factory or one unlucky model. It is the same flaw across brands that spent decades competing on reliability. Not sabotage, not a secret, just physics, pushing back on an impossible demand. Let's start with the scale, because the numbers are staggering. In April 2025, General Motors recalled around 720,000 of its 6.2-liter V8 trucks and SUVs, the engines in Silverados, Tahoes, Yukons, and Escalades. Toyota, the brand practically built on the myth of running forever, recalled 102,000 of its twin-turbo V6 engines, then quietly added another 127,000. Honda recalled roughly 250,000 of its 3.5-liter V6s for connecting rod failures. And then regulators opened a probe covering another 1.4 million Hondas. Hyundai and Kia have now recalled more than 3 million engines across multiple campaigns, facing a bill that could top $5 billion. Nissan recalled roughly 500,000 of its variable compression turbo engines, found in the Rogue, the Altima, and several Infinitis, over the same kind of bearing failure. And even Stellantis got pulled in, recalling over 100,000 turbo 4-cylinder engines after finding sand left inside the engine blocks. Different badges, different price tags, but the exact same symptom. Bearings destroyed, engines seizing, and some of them dying before the first oil change. So what is actually going on? The answer starts with a number almost nobody thinks about: power per liter. Back in the 1990s, a big, lazy 6-liter V8 made around 60 horsepower for every liter of displacement. Today, a tiny turbocharged engine half that size makes twice as much, over 120 horsepower per liter, numbers that used to live only on a racetrack. Double the power, half the metal, and all of that extra heat and pressure loaded onto smaller, thinner parts. That alone would be a challenge. But automakers stacked something else on top of it. To squeeze out every fraction of a mile per gallon, they moved to thinner and thinner oil. The thick oils of the past gave way to 0W20, then 0W16, and in some engines 0W8, a lubricant barely thicker than water. Thin oil reduces friction and helps fuel economy, but it only protects the engine if everything is machined to near perfection. So, to make that thin oil work, automakers shrank the clearances inside the engine, the tiny gaps between the spinning crankshaft and its bearings, from around 0.003 of an inch down to as little as 0.005. Read that again? The margin of safety inside your engine shrank to a fraction of the width of a human hair, and into that impossibly tight space walked an invisible killer. Its name is Swarf. Swarf is the microscopic metal debris left behind when a factory drills, cuts, and hones an engine block. The big chips are easy to wash out. It is the near-invisible dust from honing the cylinder walls that does the damage, a razor-sharp grit harder than the bearings themselves. In an old engine, with loose clearances and thick oil, a stray speck would wash through and cause no harm. In a modern engine, tuned to the very edge, that same speck lodges between the crankshaft and a bearing and acts like sandpaper, spinning at thousands of revolutions per minute. First it scores, then it grinds. Then the engine destroys itself. The debris did not get worse over the years. The engine's tolerance for it simply vanished. And when a plant is building 10,000 engines a day, achieving hand-built, surgically clean perfection on every single one is frankly impossible. It got dramatically worse during the pandemic. Engines built between 2020 and 2022 came out of chaotic factories run by skeleton crews, leaning on brand new suppliers, with quality inspectors stretched thin. Those engines are only now reaching 60 to 100,000 miles, exactly where hidden defects finally surface. Now here is where it gets contested and genuinely interesting. Automakers overwhelmingly blame manufacturing debris, a cleaning problem, not a design problem. That distinction matters enormously, because a cleaning problem is cheap to fix, and a design problem means lawsuits and billions in redesign. But independent engine builders point to two things that don't fit the debris story. First, there are documented cases of a brand new replacement engine installed under a recall, failing again after just 6,000 miles when the original had run 76,000. A truly clean replacement shouldn't do that. And second, look closely at the fixes themselves. When the remedy for a supposed debris problem is to switch the engine to noticeably thicker oil, it quietly admits that the thin oil was never quite up to the job. If debris were the whole story, thicker oil would not be the cure. The dispute is real and still unresolved, but the engines are telling on themselves. If this is making the pieces click into place, a quick subscribe genuinely helps. Which brings us to the real question. Why would an entire industry engineer itself into this corner? The answer is regulation. For years, federal fuel economy rules, known as CAFE, ratcheted upward relentlessly, at one point demanding roughly 8 to 10% improvements year after year. Engineers did not forget how to build a durable motor. The specification they were handed changed. The fines for missing were brutal, roughly $17 per vehicle for every tenth of a mile per gallon a company fell short, which for a large automaker could add up to hundreds of millions of dollars a year. Faced with that, automakers did the cold math and decided that a predictable trickle of engine failures was cheaper than falling short of the standard. Tiny turbos, thin oil, microscopic tolerances, cylinder deactivation, every trick to save fuel, and every trick pushing the hardware closer to the edge. But here is the twist that the scarier versions of this story completely miss. That regulatory pressure has now largely collapsed. In the summer of 2025, Congress eliminated the financial penalties for missing CAFE standards entirely, resetting them to zero, and regulators moved to roll the targets back sharply toward a far gentler goal for the 2030s. On paper, the whip that drove this whole mess is gone. So the crisis should be over, right? Not even close. Because none of that unbuilds the tens of millions of fragile, edge-of-tolerance engines already sitting in driveways and still rolling off assembly lines today. No automaker tears up a billion-dollar engine program overnight, and the same recipe that caused this is baked into current production. The relief is real. The damage is already cast in metal. So what does this mean for you, the person who just wants a truck that lasts? A few practical things, and none of them require panic. First, spend 2 minutes and check your VIN on the Federal Recall Lookup tool at NHTSA's website. If your engine is named in a recall or an investigation, get it handled, because these failures often arrive with almost no warning and finish the next. Second, change your oil more often than the manual's stretched-out interval suggests. An extra oil change or two a year is nothing next to a $15,000 engine. Third, if you're shopping used, be genuinely cautious with heavily downsized turbo engines from the chaotic 2020 to 2024 build years. And think hard about a warranty that specifically covers internal engine parts. A proven, simpler engine with high miles can be a safer bet than a stressed modern one with low miles. Because the bottom line is this: these engines are not failing because of bad luck, and they are not failing because of some cartoon conspiracy. They are failing because an entire industry was pushed, and pushed itself, to build race car-grade engines at the scale of millions, where the margin for error shrank to the width of a metal shaving. The engines have been telling the truth the whole time. The only open question now is whether the industry, finally handed a little breathing room, will actually use it to build engines that last again. or keep the recipe that got us here simply because it has already been paid for. Check your recall, change your oil, and subscribe.